Welcome to Grateful, where we offer one-on-one and small group online SAT and ACT instruction to students all around the world. If you're interested in finding out more about how we can help you to prepare for the SAT or ACT, feel free to reach out. Right now, we're looking at the March 2020 Section 3 No Calculator Math section, and let's go ahead and jump right in. So on question 1 here, we're being asked to find the equation of this function. And one thing we want to point out is that all 4 answer choices are linear. They're all in the format of y equals mx plus b. And the whole idea of a linear equation is that your slope is the change in y over change in x, and usually the bottom is a 1. So it's your change in y for every change in 1 of x. So like in other words, every time x increases by 1, what is y increasing by? And here, that's nice and easy because the y is also increasing by 1. So we know that the slope is 1. So in our y equals mx plus b, we'll put a 1 in front of the x, and now we just need the y-intercept. Now your y-intercept is what you have when x equals 0. So x equals 0 right here, and you can put in a 2 for the y-intercept. So we'll put a 2 right here, y equals x plus 2, and the answer for number 1 is A. Question number 2 is asking about parallel lines. And before we get into it, we want to know that parallel lines come down to C's and Z's. So what do we mean by that? We mean that if you see a Z shape or a backward Z shape, then you're supposed to know that the 2 elbows of the Z are equal to each other. So if here we have angles A and B, then they're going to always be equal to each other. But if you had a similar situation where instead of a Z shape we have a C shape, then you're supposed to know that the elbows in this situation add up to 180. So A plus B equals 180. So let's see how many C's and Z's we can point out here. If L and M are parallel, that gives us a Z shape right here. So we know that this angle is 40, because for Z's, the 2 angles are equal. Now for this 80-degree angle right here, we have a vertical angle on the opposite side, so that's 80 right there. Now, because the angles of a triangle add to 180, we already have 40 and 80, which adds to 120, so we need 60 more to make this yellow triangle here add up to 180. So we now know that we have a 60 there. Now using vertical angles again, we know that this angle here is equal to this angle here, and so they're both equal to 60. Now if we change our attention here and focus instead on these 2 parallel lines, this one and this one, what we'll see is that we have yet another Z shape. We have one right here going like that. So with an 80-degree angle in one elbow of the Z, we now know we need an 80-degree angle in the other elbow of the Z. So for this straight angle right here that's composed of the 60, the 80, and the x, we know that straight angles add up to 180. So what we can say is 60 plus 80 plus x adds up to 180, and we can just go ahead and solve that. 140 plus x equals 180, and we can take away 40 from both sides, and we'll get x equals 40, and the answer for number 2 is A. Question number 3 is basically just asking us about f of x notation. If this is our f of x right here, and then they ask us for f of 4, we're supposed to know that that means plug in 4 as your x value. So if we plug in 4, we'll have 4 squared minus 5 times 4 plus 6. So that's 16 minus 20 plus 6. 16 minus 20 is negative 4 plus 6 is positive 2. And the answer to number 3 is B. Question number 4 is mainly asking us about price times quantity statements, PQ statements for short. And before you start one of these longer word problems, you really want to clearly define for yourself what the variables that are given to you stand for. So S is the number of packs of streamers. If I were doing this on a real SAT on my own, I might take a second to write that out. And B is the number of packs of balloons. So if we're setting up a price times quantity statement, we know that for the streamers, they're 149 each, and we have S of those. And for the balloons, they are 439 per pack, and we have B of those. Now the question is telling us that this amount of money, both of the price times quantity statements put together, should be less than or equal to 20. And that's because the person here only has $20 to spend. So both of these things put together has to be less than or equal to 20, and that matches answer choice B for number 4. Number 5 is giving us a linear situation and asking us to put the equation together for that. And the one thing you want to kind of know here is that for a lot of these linear situation word problems, it really looks the same if you're not careful about it as far as whether or not it's something that's increasing, because if we were charting the number of miles driven, it would be a linear situation that's increasing, or the amount that's remaining if we had a linear situation and we were being asked about the amount that's remaining. So here we want to be really aware that they're asking us for the remaining distance. And so now, thinking of that as a y equals mx plus b, it means that initially there's 1,000 remaining, and we're going to be taking away 250 per day, and n is the number of days. And all of that is going to give us the distance remaining. So if we switch that, instead of mx plus b into a b plus mx, that's going to give us 1,000 minus 250n. And that matches answer choice D for number 5. Number 6 is a nice straightforward question that a lot of people miss, because if you're in a rush, you'll think that you have one parentheses here and one parentheses here, and you'll think they're being multiplied. So most of the people that miss this question will inadvertently FOIL this situation. But we're not being asked to multiply them, we're being asked to add them. And because there's no negative sign or no number in front of this parentheses here, we really don't need any of the parentheses. So we can rewrite this with no parentheses, x cubed plus x squared minus x, and then just combine our like terms. The like terms right here are just the x's. The x cubed and x squared, those are not like terms. So we'll have x cubed and x squared, and the two x's cancel against each other, and the answer for number 6 is C. So number 7 is simply asking us to graph the values from this xy table that we're being given. First of all, you need to know, if you don't already know, that f of x is just a fancy way of saying y. Another thing that's important here is that we have deceptive grid lines, because if you look closely, each of these lines is counting for 2. So for instance, right here we have 2, 4, 6, and 8. And knowing that those are 2 makes a big difference on how we're going to graph this. So what I personally would do here is just go ahead and try to graph this situation on my own. So let's go ahead and put grid lines that are equal to 2 so that we can match the situation we're seeing in these graphs. And the first point is -2, -2. Then we have -1 and 3, which will be right here if each line counts for 2 spaces. Then we have 0, 2, 1, and 7, that'll be right here. And 2 and 30 will be some value way up off the chart. So looking at the way this graph pans out, it'll look a little something like this. So now that easily means that B is wrong because we don't see it curving back downward around here. So that gets rid of B. We also know that C is wrong because we don't see it touching the axis right here when it dips back down. So that's C. And we can also say that A is wrong because right around here, this function creeps up to a height of about 6, whereas for us, it was only at a height of 3 at that point. And so that gets rid of A, and the answer for number 7 is D. Question number 8 is really asking us about whether we understand that x plus 2 squared is really x plus 2 times x plus 2. And once we can cancel the x plus 2 in the numerator against the x plus 2 in the denominator, it's also quizzing us on the idea of knowing that underneath that x plus 2, when it cancels away, there's an invisible number 1 that was really there all along, but we don't write because we didn't need it at that moment. So our answer is 1 over x plus 2, and that's B for number 8. So question number 9 is asking us about a line, and it's giving us 2 points, and you definitely want to know how to write the equation of a line when given 2 points. Now there are 2 ways to write the equation of a line. If you're given a slope and a y-intercept, then you're going to want to use the slope-intercept formula of a line, y equals mx plus b. But if you're given a point and a slope, then you're going to want to use the point-slope formula of a line, which is y minus y1 equals m parentheses x minus x1. And that's what we're going to want to use here because we're given 2 points, we're definitely given 1 point, and we're given the slope because if I give you 2 points, I'm giving you the slope. So the slope formula is y2 minus y1 over x2 minus x1, and we can just go ahead and plug in the points we have here. That would be 15 minus 3 over 5 minus 1. So 15 minus 3 is 12, 5 minus 1 is 4, and that simplifies to 3. So we just figured out that our slope is 3, and that takes care of it already because there's only one linear equation with a slope of 3, and that's answer choice A. Now if we needed to find the equation of the line, by the way, we could plug it into this formula, and it would be y minus 3 equals 3, x minus 1, and we can go ahead and distribute and get y by itself, and it would look like a y equals mx plus b. Now we're just explaining that because that's a really valuable skill. Finding the equation of a line when you're given 2 points is one of your fundamentals that you really want to be good at for the SAT. Now question number 10 is talking about a really high-level math skill that in my opinion comes up at least once on every current SAT that's being offered, and that's the idea of seeing an equation as an expression of an intersection. Now, if you're asked for an intersection of 2 functions, what you're generally going to want to do is get both of them in the y equals format and set them equal. So that means that the opposite is true. When I see an equation, I can think of it as the expression of 2 functions that are already being intersected with one another. So I can see it as y equals 4x plus b over 2 and y equals 2x plus 8. And what we're looking at right here is the idea of someone, let's just say, imagining where do these 2 functions intersect. And so we're talking about 2 lines, first of all, because lines always have x and y to the first power, and there are 3 ways that 2 lines can interact on an xy axis. They can hit once, they can hit never, or they can hit all the time. That's the idea that when you go to graph the second line, you realize it was really the same line all along. And when they're hitting once, that usually means that the slope and y-intercept are different. When they're hitting never, that means that the slopes are the same and the y-intercepts are different. And if they hit all the time, infinite solutions, that means that the slope and y-intercept are both the same. And once again, that's the idea of having one solution, no solutions, and infinite solutions. So now what we're doing is we're taking what was given to us right here in green and realizing that that's a reference to an idea that comes up frequently on the SAT. This is an expression of 2 lines that are intersecting, and when they do, they have infinitely many solutions, which means that they're the same line. Now there are a lot of ways to do that mathematically, but what you want to do is kind of use generally the same method every time you're doing these repeating questions, so you can just be more and more confident with that. So for this line, it's kind of easy. It's a y equals mx plus b, and it means that the slope is the 2 and the y-intercept is 8. So if we can get the other one in y equals mx plus b format, we can set both of those parts equal. For this one, we have to kind of divide it out. The little rule there is that a plus b over c is the same as a over c plus b over c. So if we do that on the left part, the 4x plus b over 2, that means that we have y equals 4x over 2 plus b over 2. Further simplifying, that's y equals 2x plus b over 2. And what we said earlier is that because there's infinite solutions, they're really the same line, the two slopes must be the same, which they are, they're both 2, and the two y-intercepts must also be equal. So this gives us the right to say that b over 2 equals 8. Multiplying both sides by 2, we get b equals 16, and the answer for number 10 is D. Going to question number 11 now. We have this trapezoid figure here, and you need to know the area of a trapezoid, which is 1/2 times b1 plus b2 times h. So definitely commit that to memory. You don't want to enter an SAT without it. And here we have our two bases, 4 and 7, and we have our height of 4. So what we're really saying is that this 5 right here is just decoy information. So let's just plug that into the formula. 1/2, 4 plus 7 times 4. And so the 1/2 times 4 becomes a 2. And we have 4 plus 7, which is 11. And our answer is 22. And the answer for 11 is B. Number 12 is a really hard question if you don't realize that there's a little reference being given to us, which is the idea that to find a y-intercept, that means that x is 0. So let's go ahead and do that. Y equals 4 to the 0. Anything to the 0 power is 1. And now we know that the answers have to be either C or D because they both have a y value of 1. And we also already knew that x was 0. So that narrows it to answer choice C for number 12. Question number 13 is giving us a nice quadratic equation. And when you have a quadratic and you're finding the solutions, you want to set one side equal to 0, which we're doing by subtracting 2x and 1 from both sides. So that'll give us x squared minus 16x plus 39 equals 0. And now we're in a BC factoring situation where we want to look for two numbers that add to negative 16 and multiply to 39, and those numbers are 3 and 13. Because 3 times 13 is 39, and 3 plus 13 is 16. And so we have it factored. Now the zero product rule says you set each piece equal to 0. And you can go ahead and solve each of these by adding 3 to both sides, by adding 13 to both sides, and our solutions are 3 and 13, and the sum of the solutions is 16, and the answer for 13 is D. Now for question number 14, we're being asked for the speed of the object, which is v, and it's a fairly lengthy process to get that. So first, we want to just go ahead and realize that v is inside of that radical, and we can't really do much until we get the radical by itself. So let's start by just dividing both sides by s, and so that'll give us L over S equals the square root of 1 minus v squared over c squared. Now, because we're trying to get to that v inside of the radical, we should square both sides. So if we do that, we'll get L squared over S squared equals 1 minus v squared over c squared. So the next step to getting the v by itself is to get that v squared over c squared by itself. So let's just go ahead and take away 1 from both sides. L squared over s squared minus 1 equals negative v squared over c squared. Now we're going to end up taking a square root on the right hand side there, and looking ahead to that, we're not going to want that negative sign there. So let's just go ahead and multiply both sides by negative 1. But something really interesting comes up. For a difference, if I have a difference, a minus b, and I multiply it by a negative sign, a negative 1 or a negative sign, however you want to think about it, that's going to actually give me b minus a. So that's a nice little shortcut. When you have things that are subtracted, when you have a difference, you can actually reverse the order by either multiplying by negative 1 or in some situations factoring out a negative sign. So what I'm saying is, if we make this v squared over c squared positive, then we can just rewrite the other side as 1 minus L squared over S squared. And it's a neat little trick that's been coming up here and there on SATs. So now, one nice thing to do would be to take the square root of both sides. So if we do the square root of what we have on the left, it looks like this. And the square root of what we have on the right looks like this. So we've got it looking a lot more simple. And now we can just multiply both sides by c, and we'll have v equals c times the square root of 1 minus L squared over S squared. And that gives us answer choice A for number 14. Question number 15 is asking us about exponential equations. And exponential equations have the general format of y equals a times b to the x. Now, for this format, we want to know that a is the starting amount, b is how it's changing. Let's just say it's doubling or something like that, or in this case, it'll be going by 1/2. And x is the number of times that that's going to happen. Now, what the SAT will do a lot of will be the idea of that exponent either being divided or multiplied by something. So if we said y equals a times b, let's say, to the x over 5, that means that this change we're talking about, maybe doubling or halving, is happening every 5 years or every 5 days. So let's just say every 5 years. And if instead of dividing it, we're multiplying it, a times b to the 5x, that would be happening 5 times per year. So you want to be really familiar with those because they come up like crazy on the SAT. Here, we know that this is a half-life. So whatever we're talking about is being halved. So in our y equals a times b to the x, the b, the change, is 1/2. We're told that the starting amount is 200 grams. So that goes right here, where the starting amount is. And the most important part of all of this is that it's happening every 150 years. Because if the half-life is 150 years, it means that it's shrinking by a factor of 1/2 every 150 years. So that's x over 150 according to this rule that we showed right here. And that's our answer for number 15. It's answer choice D. Now we're going to question 16. We have a y equals mx plus b. M is the slope, b is the y-intercept. And we're seeing that the slope, which is our rise over run, as you go from left to right, is rising by 2, running by 1. And so the slope is simply 2. And question number 16 is that easy. Now going to question 17. It looks a little more complicated than it is, and the reason why it's easier than we think is because right here we have only one variable. If we divide both sides by 2, we have x equals 5 over 2. Now we can just take that and plug it in as x in the other equation. 5 over 2 plus y equals 5. There are a ton of ways to solve this, but let's just go ahead and multiply both sides by 2. That would give us 5 plus 2y equals 10. Take away 5 from both sides, 2y equals 5. And y, coincidentally, is 5 over 2, just like x. And that's our answer for number 17. Question number 18 is asking us about the zero product rule. And just to give you a little background on that, I'm going to lay out something that I call the quadratic sequence. It's just the nice, easy thing that you do whenever you're solving for the zeros or x-intercepts of a quadratic. So let's say that we had y equals x squared plus 7x plus 10, and a question said find the x-intercepts. Well, we need to know that the x-intercept means that y is 0, so we're going to set it equal to 0. That's our permission to factor. Two numbers that add to 7 and multiply to 10 are going to be 2 and 5. And now we have the zero product rule, which says that if these two parentheses multiply to 0, that means that one of them had to at least be 0, so you set them both equal to 0. And now you just solve each one, and you get your answers. Now, these answers here at the bottom, the -2 and the -5, the SAT will refer to those as x-intercepts, roots, zeros, or solutions. But the corresponding parts for them up above here, those are called factors. So we're talking about a lot of terms that all mean the same thing. But What you really want to do is you want to notice that in this quadratic sequence, what we're being given right now is essentially, if I can put numbers on these steps, this is step 1, this is step 2, this is step 3, step 4, and step 5. So we want to identify that what we're being given here is actually step 3 in a quadratic sequence. Because if you got your parentheses and you've got them multiplied out to equal 0. So if we can take that to step 4, what we're basically saying is that each of these parentheses, ignoring the 5 because it's kind of meaningless, if you divided both sides by 5 right now, the 5 would disappear. So each of the parentheses gets set equal to 0 according to the zero product rule. Now we can take it to step 5 where we solve each of these. X equals 3, x equals -1, and which of these is a positive value that satisfies it? The 3. So the answer for 18 is 3. For number 19, we're just solving a basic equation, so we can just go ahead and add 0.6 to both sides, and that'll give us 3x equals 2.4, and now we're just dividing both sides by 3. What number times 3 equals 2.4? And that's 0.8. If you can think of it in your head, 8 times 3 is 24, so 0.8 times 3 is 2.4. And the answer to number 19 is 0.8. Now question 20 is asking us about a square inscribed in a circle. So let's draw a circle, and then we're going to place a square inside of it. And we know that the radius of the circle is 6√2. So let's go ahead and draw the radius as it pertains to this shape, and that's right here. This is the radius that kind of matters for us, and it has a length of 6√2. If we take that radius in the other direction, we have another 6√2. And what's happening right now is that we have an isosceles right triangle with a hypotenuse length of 12√2. Now we need to know as a rule that any isosceles right triangle is a 45-45-90 triangle. And the 45-45-90 ratio is given to you in the formula sheet for the SAT, but really you shouldn't have to use it because you should know special triangles well enough to quickly just be able to draw one and state that the three sides are x, x, and x√2. Now the side that's equal to x√2 we already knew was equal to 12√2. So that's telling us that x is 12, and we just figured out that the side lengths of the square are 12. So if the square has sides of 12, what's the perimeter of the square? 48, and that's our answer for number 20. Thanks so much for joining us as we've gone through the March 2020 SAT's non-calculator math section. Once again, Grateful Test Prep provides one-on-one and small group online SAT and ACT instruction to students all around the world. If you're interested in finding out how we can help you prepare for the SAT, go ahead and reach out. Thanks so much and have a great day.